Hello, everyone. Thank you for joining us today. My name is Tom Hallstrom, and I'm joined by Chuanli Zhang. And today we're going to be talking about how predictive planning can add value in the healthcare space. Quick note about me, I am a director of client development here at Blueprint. I head up our healthcare practice, and I'm personally very passionate about leveraging technology and data science to positively impact the patient experience. In addition to healthcare practices, my background and expertise is in the modern workplace. And again, finding ways for technology to serve the business. And one way that has played out is being heavily involved with our nonprofit portfolio and finding how can we give nonprofits, especially health and human services nonprofits, the same advantages that the for-profit commercial industry has available to them. So as I work on things like that, I will proudly and loudly say I am not a data scientist, but I see the value in how it can improve the patient experience. And that's why I really enjoy getting to work with someone like Chuanli.
Thanks, Tom. Hello, everyone. This is Chuanli, one of the data scientists here at Blueprint. I was originally trained as a climate data scientist, spending many years in academia. But for the last 5 years, I have extended my interest to healthcare, retail, and service industry. Glad to share some of our work today.
Cool. Well, let's get started. So why do we think the healthcare industry is ripe for something like value-driven predictive planning? For over 30 years, the healthcare industry has relied on a fee-for-service model. So providers would deliver services, treat patients, discharge them, and then bill for those services via insurance payers with really little accountability for the health and well-being of the patient. And as a result of the Affordable Care Act, there's been a real fundamental shift in that model, moving from fee-for-service into pay for performance. And this new model requires really high accountability for a patient's health and well-being, and requires contextual awareness of what other care is being provided for someone and how does that impact the services that are being given. And this transformation really demands a fundamental change in the business strategy that healthcare organizations are employing. Being able to deliver real, reliable, meaningful insights to decision makers that are tied to real outcomes can help shape your organization's strategy and your ability to know how you're performing, what's currently going on, what will be going on in the future, provide the best care possible for your patients, and help you hold on to the talent that you've worked really hard to onboard to your organization. So that sea change is really kind of the stage on which we're talking about predictive planning. So kind of the framework we want to talk about, and whether you are a decision maker, you are the CIO, you are frontline provider, you're kind of more back office business intelligence staff, this model still is relevant for you. And really the thought is, can we take something like a data science model, apply it to the planning and scheduling process, and then yield relevant, informative insights that can be used to then feed back into the beginning of the process, improve the model, improve the scheduling process, and figure out, when somebody doesn't show up for an appointment and you're looking for ways to intervene, are you basing those ideas for intervention on kind of gut feel or your past experience? Or are you maybe letting the data suggest what would be the most profitable or the most successful or most efficient path forward? So we're going to be using this model to kind of talk about some additional use cases. So let's jump right in. What do we got here? We have a bunch of data. Fear not, this data has been synthesized. So we made it up. But when experimenting and working on these data science projects, we can quickly generate mock patient records and then use those to identify patterns. So this has everything from the patient's name and gender to things like how long has it been since their last appointment? How far out is their next appointment scheduled? What's their age? What's their zip code? Maybe in this case, what clinic, we're going to be assuming we have like a 3-clinic model. What clinic do they regularly visit? What type of insurance do they have? So we're going to take some of this raw data and we're going to ask it some questions and see what it tells us. So what I just showed you, synthetic or not, this can be data that came from, let's say, your electronic health record system. The problem is in most healthcare organizations, as you've slowly matured and built up, there are lots of different types of information repositories, document management systems, lab results are stored in one space, operating rooms are scheduled in another, patient records are stored elsewhere. And it's really tough to ask questions of your data and see what it can tell you when you have so many different silos that you need to ask the same questions of. And what I briefly want to mention is, you may already be familiar with it, but the FHIR, F-H-I-R, Fast Healthcare Interoperability Record, is a new, slowly being adopted data format, which basically just, it's a common language. So whether you have Epic as your EHR or NextGen or Cerner, or you're using Microsoft's Office 365 or whatever your tool set is, it's a standard way of saying, we're going to refer to patients like this. We're going to refer to their demographics like this. We're going to refer to encounters and diagnoses like this. And it's a standard model. So when you introduce these disparate data sources into this FHIR model, it allows you to ask the question once across multiple silos and get interesting information. And that's one of the tools in our toolbox that we've done some work with today. And whether you know a lot or a little about the technology that your organization implies, I show this noisy little graphic just to say, the point of this, of what we're talking about, is not just to flex our data science capabilities or create some really interesting models or graphs or charts, but it's to take just about any kind of data. Maybe you're a Microsoft organization. Maybe you're not. Maybe you have a bunch of stuff in the cloud. Maybe your organization is a little slow to move to the cloud and it's all on premise. The point is to take that data, that FHIR that we talked about right here, standardizing a lot of it, putting it into the cloud or a place that you can work from, and then have some report authoring tools. In this case, we use a little Power BI, some Excel. These are Microsoft tools, but there's lots of companion authoring tools out there. And the end goal is to make that all available wherever your organization needs it. So maybe you have mobile medical teams. One of my clients has mobile medical teams who are regularly going out and serving the homeless population. And them being able to not have to write things down, go back to the office, and then connect to the network and get the information they need. If they can get some of that information, maybe it's patient information, maybe it's knowledge lookup, get that on their phone. The point is, how can we get the data into the hands of the people that need it when they need it? So maybe that's on their phone out in the field. Maybe that's your back office business intelligence staff figuring things out on their desktop, or maybe that's your providers. That could be, frontline care staff trying to figure out the best way to schedule an emergency department for the night. So the point of all of this is to use all of the technology to ultimately positively impact the provider and ultimately the patient experience. So first thing we're going to quickly run through is a growth chart. Not very complex or sophisticated, but what I wanted to show is how quickly you can ask questions of this raw data and yield insight from it. So this is what we recently shared. When we apply that FHIR, F-H-I-R, data standard, all of a sudden it turns this into an organized list of patient first and last name and their age. And then, since we have a standard, we've got a listing of conditions. And these conditions, pre-diabetes has the same unique identifier across multiple data repositories and multiple patients, multiple conditions, multiple encounters. How are we classifying different times that this particular, Raphael Trump has come in to the clinic and had an appointment? And finally, observations, which have their own unique identifier. And what you can do is take that FHIR data standard, run it against your raw data from multiple repositories, and very quickly yield some interesting data visualizations. Now this is, a BMI and height and weight chart saying, all right, where does this person fit against, the national index? And I share this to say some of these tools, in this case, we use some Microsoft tools, but these tools are available. And if you're a nonprofit, they're available sometimes for free. You can spin this up in 10 minutes. I'm not a data scientist. I was able to kind of run a little lab experiment and do this myself in less than 10 minutes. So one of the things we want to talk about today, and happy to talk about if you want to follow up after this webinar, is what kind of tools are available and how can we let you know about which ones are really easy to use, which ones are free, which ones would best suit how you operate and could ultimately help you make decisions more informed or in ways that improve the patient experience. So that was a growth chart. That was fast. Let's talk about no-shows, the crown jewel of today's webinar. So why talk about predictive planning around no-shows? Well, the research shows in North America, no-shows average about 27%, which is a lot higher than I was expecting. I try to personally make sure I'm showing up closer to 100% of the time. They're occurring around 200 million times per year, which results in some serious cost. And it's not just the lost revenue if you've got providers standing around. It's also the fact that an ounce of prevention is worth a pound of cure. And if some of these folks aren't showing up for care early whatever their diagnosis is, a few successive no-shows, you can add weeks or even months, and the scenario can really worsen, which is a lot more costly and a lot more dangerous to treat. So there's a lot of negative impact from folks not showing up. And there's a number of intervention solutions which are out there, but where Blueprint thinks that they fall short is many of them are simply reporting, yep, turns out, we ran a little demographic analysis of this patient and looks like they're not going to show, maybe a percentage. They're 27% not likely to show. But that doesn't really tell you what you should do. It's just telling you what will likely happen. And what Blueprint considers unique to its solution to this is how can we use the data to not just predict what's going to happen, but to provide intervention options. In the case of no-show, we'll get into some of what those intervention options are. And then measure those and like we talked at the beginning, constantly refine the process so that when you intervene, you're able to figure out whether electronic follow-up is most useful, or in-person follow-up is most useful, and then adjust your processes accordingly. And even minor improvement in no-show rates, depending on your clinic traffic, can result in significant savings. So here's a little sample dashboard that we created. And what I want to point out is each of these little cards. This is Power BI. We do a lot of Microsoft work. We're based in the Pacific Northwest, so Redmond is our neighbor. And in this case, we use Power BI. There's lots of data visualization tools, and we work with quite a few of them, but that's what we're using today. Each of these cards is preceded by a question. And I want to take this opportunity to say there are some things that the data, that the machines will never be able to do that are distinctly human. And three of those things are creativity, empathy, and judgment. And oftentimes, so much time is spent collecting data and measuring the data and manually looking for patterns in the data, things that can be fairly fatiguing, that you spend so much time collecting and measuring, there's no time left for that creativity and empathy and judgment. And our thought, let's let the machines do what they're really good at, those mind-numbing, fatigue-inducing activities. See, they're really good at pattern analysis and recognition. And then if we kind of outsource those tasks to the machines, then we've got a lot more time left to really spend on creatively analyzing the data. I say all that to say, you've got to bring, no matter what the tech, no matter how sophisticated the technology solutions are that you're bringing, that you have at your disposal, you can't start with the tech, or it's going to be the tail wagging the dog. You really need to come with questions. You've got to bring a question to the data, and it can yield really interesting insights, but you've got to start with a question. So here, I like to make sure that rather than just getting clever with your charts and coming up with interesting insights from the data, that you're always making sure, is this framed in a question that yields a useful answer? So here we've got some fairly descriptive questions that we're asking. How many patients does our particular clinic serve on a regular basis? What's the insurance distribution look like? What are the cost of these encounters? And those are, historical kind of questions. What gets interesting is when you start getting into not just what is happening, but asking what will happen. How many no-shows are expected in the next 6 weeks? And you can start asking interesting questions of the data. Now, this is a flat dashboard, but a lot of the data visualization tools out there, you can start doing things like clicking into these charts and saying, okay, what if I limit it to a particular age group? And as you start experimenting, you can start seeing, man, does tobacco cessation influence whether someone's likely to show? Does distance from the clinic? Does their type of insurance, gender, age? And then you can move not just from what is happening to questions of what will happen. This last one is what should happen. And this is tricky. Data science is a powerful tool. Pick your example of sci-fi movie where we're asking the data to do more and more and more for us and having it turn south, right? But just because it's a powerful, potentially dangerous tool doesn't mean it's not a powerful, potentially useful tool. And so in this case, we're going to talk a little bit about the background, but what would it look like to say how many no-shows are expected at your clinic in the next 6 weeks? And then for some machine learning and deep learning to say, here's what we've found. A call makes sense to intervene. This is going to be fairly high likelihood of having the patient show. With a lot of the nonprofit clients that Chuan Li and I work with, Some of these folks are in transitional housing and don't have a phone, don't have access to the internet. So that's where it takes empathy and judgment, human empathy and judgment, to say, these folks don't have access to that. We're not going to assume a level of infrastructure that's not available to them. It may be that starting a shuttle service to go pick them up makes the most sense. Or maybe partnering with an existing shuttle service rather than trying to start something from the ground up inside. But this is an example of, when it comes to no-shows, what kind of questions are you asking about the problem? And recognizing that different types of questions require different types of analytics. So I'm going to hand it over to Chuan Lee to talk a little bit about kind of the underlying science behind it.
Okay, to get there, for predictive models, we used random forest and support vector machine algorithms to predict not only who will no-show, but also when and why. So those models are able to identify a list of at-risk patients for no-shows. And for those of you who are really interested into the nitty-gritty details of those algorithms, please check out our GitHub post for details. So for the at-risk patients, a simple dashboard like the one Tom just showed, or a smart scheduling product can be built to not only visualize who will not no-show, but also list all those intervention options for that specific patient to remind them to come to the clinic. So here I'm showing you a prototype of UI that we built on React JavaScript. So a scheduler can see all those at-risk patients on an actual calendar for next week or even next month. And so the scheduler is able to click on specific at-risk patient, and on the right side, there's detailed information will be shown. And in addition to that, the scheduler can also click on one of the recommended intervention options for that specific at-risk patients for reminders. And all this data will be able to update it in the database for future uses and analysis.
So a note I want to mention here, there's, we have the Power BI dashboard, and then this UI. Really what we're showing you is kind of welcoming you into the workshop and talking about, here's some of the proofs of concept and solutions and approach that we're thinking about to solve this problem. And really it depends on your organization. So back to my earlier point about, maybe this needs to be on mobile, on phones, maybe this needs to be on a desktop, maybe this is a little app that's on a tablet down in your emergency department. It's more about meeting people where they're at. So if a dashboard like the one that I showed earlier is useful and provides insight, great. If it's not, don't use that. If you need to provide your scheduling staff, for them, a scorecard kind of dashboard is far less valuable than a calendar. Now, this little proof of concept that Chuan Lee has built, we recognize there's a lot you can do in a standalone scheduling app, but most organizations are already going to have a scheduling solution that is integrated with all other kinds of, line of business applications. And what we're thinking about is, man, can we create a solution like this, exactly as Chuan Lee was saying, where it writes that data back to the smart schedule, to the, let's say, the EHR, the scheduling system? Or could we integrate this kind of logic where the scheduling team doesn't ever need to leave their native scheduling tool, and it is automatically funneling certain types of patients towards high confidence time slots? So where you're seeing different types of interfaces, what we're looking at is different ways of approaching the problem. And we're kind of letting you into our thought process and philosophy of how we should approach it and really enable smart scheduling with as little friction as possible. Exactly. And most use of native apps as possible.
Exactly. With those continuous optimization and development, ultimately we can rank those intervention options to identify the most efficient interventions for our populations. In this case, for this specific population, the lead time to their appointment and other features, including the smoking, became the top key drivers or root causes for the no-shows. So with this insights, the decision makers can better understand their patients and why they not showing up for their.
And one note about that, back to the creativity, empathy, and judgment. It's interesting to see what kind of patterns the data yields. Some things like, hey, if they've had 5 prior missed appointments, it's likely that the 6th will be missed as well. That makes sense. The tobacco one is a little less intuitive, but if you start thinking, okay, tobacco use, the dangers of tobacco use are well publicized. So someone who is a lifelong tobacco user is used to stalling sound medical decisions. That can certainly influence a behavior pattern of, you know what, I don't want to go this week, I'm going to go next week, and pushing some of those things off. And that's an instance where the data can yield an interesting insight, like tobacco use, does it influence no-shows? And then you exercise that creativity and empathy and judgment to kind of dig into why that might be a factor. And that leads to options ranking. So while we have, while the data may say, here are some of the key drivers for someone not showing, then you start talking about, okay, what can we do to intervene? And
yeah, in this case, after aggregation, we found that emails are the most effective intervention options for this particular population. So this piece of insight is really useful to scale the best practice for other patients, for other clinics.
Yeah, and being able to tune your intervention for different populations, if you're a nonprofit, if you're focused on Medicaid patients or not, if you're in an urban area or more of a rural area, this is where you can kind of experiment with different types of interventions and then make adjustments, get creative suggestions from all levels within your organization, and then feed that into the system and see what works. So at Blueprint, we strongly believe that the technology should serve the business and be tied to business outcomes and not exist for its own sake. In this case, the business value for predictive planning is you're able to use machine learning algorithms to predict not just who's not likely to show, but really understand the root cause and then act on it. Not just get an inert report, but to provide insight on how can you intervene, how can you make sure this person receives the care that they need. And quantifying and recommending those interventions and allowing you to adjust and refine and recalibrate. And not only does that reduce your no-show rate, but as it says, quantifying the improvements in your patient provider sat, your engagement scores, hospital, readmission scores, disease diagnosis. This is the third of our use cases that we're going to walk through. Chuan-Li?
All right, so let's start to answer the question of why this is important by a persona that is based on my family's personal experience. Suppose a patient came to the clinic because she had been coughing for over a month and none of the antibiotics she was using worked. So her doctor, had a few suspicions in mind, but he knew that the patient need immediate treatment plan. So he sent the patient to a radiologist for chest X-rays. So the radiologist took some images, and she had some, some ideas on her mind. But instead of sending this patient's images to, a pile of other patients' images to wait, she uploaded her information images to a radiologist assistant software on her desk. And this assistant provide a few more, possibilities. So the radiologist was able to, weigh in this assistant second opinion and her expertise to provide very useful diagnosis information for the doctor. So the doctor was able to provide very immediate diagnosis for that woman and discuss, immediate treatment for her. So with that, this radiologist assistant can be built upon a deep learning algorithm that, for example, Chestnut, which is a paper published in 2017 by Stanford University researchers. So this assistant or deep learning algorithms mimic the diagnostic process of a real radiologist, and it has seen millions of images, and it came up a internal mechanism to classify the disease. So for those of you who is really interested into this Chestnut algorithm, including its theory, architecture, performance, please go check out our GitHub post. So here, the output of this assistant can look like this. So for this 8 lung disease classes, the red boxes show the radiologist real diagnosis, and the blue boxes show the Chestnut model predictions. You can see that the model predict the disease classes pretty well, but the margins or areas of those affected regions can differ from the ground truth. So for those of you who, like me, wants to, upload your own X-rays and use this trained radiologist assistant to test the result, to get a second opinion, here is a UI prototype that I built on the top of the back-end Chestnut deep learning algorithm. So what you can do is you choose a X-ray images from your local computer and upload it to that server where the model lives, and you can display this X-rays right here. And then you click upload, and you can see that the model, the Chestnut model, is doing the work to predict. And then after a few seconds, you can see the diagnosed results of a pneumonia with 85% of certain probabilities. So that's the use cases of the disease diagnosis.
So we've answered some different types of questions today, and I want to put these use cases up against a fairly common analytics spectrum. What you see here is going from descriptive analytics, which are really, performance management. It's focused on planning and analysis of, historical, what has happened. moving in, and that's the growth chart. How many people have had their height, weight, and BMI measured, and where do I fit in that? It's very descriptive. Moving into predictive, this is more like operational intelligence, and it's these type of analytics are trying to approach delivery of real-time information to frontline staff and systems. And so things like no-shows, you got frontline scheduling staff. How can predictive analytics help no-shows? How can it improve the radiology assistant that Charlie just talked to? And then, the smart scheduling and no-show intervention, that's more prescriptive, where you're getting more into exploration and discovery. So these are, this is where I kind of think of these use cases as fitting on the analytics spectrum. But there's some others that we didn't even cover that are pretty interesting. Combined analytics, even if it's fairly basic historical information, pulling that data out of its formerly siloed repositories and doing some correlation analysis can yield interesting insights. Under predictive, maybe it's not people not showing up for an appointment, but how do you hold on to the providers that you already have? How do you figure out what's the pattern of behavior or performance right before somebody taps out, and can you mitigate that? Especially if you're a nonprofit and you're dealing with like budget constraints, and it's hard enough to get good talent to stick around, to believe in the mission. Holding on to them is really valuable. So how can you do that and avoid burnout? Pharmacy compliance, utilization forecasts, planning, future capital investments, such like new facilities or equipment utilization. You can really improve your negotiating position with insurers and get more efficient with your resource assignment when you better understand how you plan to utilize services in the future. And then for prescriptive, being able to plan investments accordingly. So there's quite a few different questions that you can ask of your data, and different types of analytics, as we've said, can answer different types of questions. So I find this a useful way of orienting our use cases and our questions. So back to the little chart we showed before. If you play the you are here game, maybe you have really strong metrics and reporting mechanisms. Or maybe you don't. Maybe you have really rudimentary scheduling and you're trying to reduce no-shows. Maybe you have no idea what kind of deep learning or data science principles can be applied to your data, but wherever you are on this chart, we would love to talk, whether that's improving your metrics, talking about some of the tools that are available, or finding ways to solve some of these problems for you if you don't have the resources for it. And specifically, that smart scheduling, getting as close as possible in your scheduling, moving your way all the way up to when the appointment is scheduled, so that you can optimize your provider and clinic utilization and efficiency, and also make sure that the patients you're trying to serve are served well and served in a timely fashion. So if any of this is resonating with you, regardless of where you're at, we'd love to talk. So thank you so much for joining today's webinar.
Thank you.
Thanks.